Welcome to qnawire.
For question 1, the exponential distribution is defined by the parameter lambda, which is the rate parameter, and the mean of mu of an exponential distribution is given as 1 over lambda. So if mu is 2, then lambda would be equal to 1 over mu, which is 1 over 2, or 0.5. For question 2, what is the probability that a random machine's lifetime will be greater than 3 years? Well, the exponential distribution is defined by the probability density function, the PDF, and that is lambda times e to the negative lambda x, and the cumulative function CDF is 1 minus e to the negative lambda x. The probability that x is greater than 3 would be 1 minus f of 3, which would be 1 minus e to the negative 0.5 times 3. And well, it'd be 1 minus that. And so it would be just e to the negative 0.5 times 3, which is 0.2231. For question 3, this probably can be found using the CDF of the exponential distribution. We need to find x such that f of x is equal to 0.98. And so 1 minus e to the negative lambda x has got to be equal to 0.98. And if you subtract 1 to both sides, or actually 0.98 to both sides, you get 0.02, and then add e to the negative lambda x. I'm going to substitute now that's negative 0.5x. Take the natural log of both sides, and then divide by negative 0.5. The natural log of 0.02 over negative 0.5 is 7.82, and that would be in years. For question 4, the 3 values that y can take on. It can take on $0 if it fails after 1 year, $250 if it fails between a half a year and 1 year, and $500 if it fails within half a year. So the probability of a full refund would be the probability that x is less than or equal to 0.5 that it fails within a half of a year. That'd be 1 minus e to the negative 0.5 times 0.5. And that is 0.2212. For question 6, we want to find the probability that x is between 0.5 and 1, which would be the same as x is less than or equal to 1 minus the probability that x is less than or equal to 0.5. And that would be 0.3935 minus 0.2212, which is 0.1723. For question 7, the probability of no refund would be probably that x is greater than 1, which is e to the negative 0.5 times 1. Which is 0.6065. And finally, question 8, the expected refund amount from the machine would be 500 times the probability of a full refund plus 250 times the probability of a partial refund plus $0 times the probability of no refund, and that equals 153.68.